Nowadays, more and more people prefer to shop online as opposed to the inconvenience of shopping at the departmental stores. Usually, such online retailers such as Amazon recommend customers similar or related products to the product they are browsing. For example, here I'm looking for the new iPad Pro and click on the first one. Here we can see that Amazon has a section called Customers who bought these items also bought, which are accessories of the iPad, such as keyboard and the pencil. We see that those products are related to each other in some sense. They are similar. In our project, we try to test and predict if two products would be bought together based on their similarities, like the case I mentioned here.
Our project is Amazon co-purchasing network analysis and prediction. According to our analysis of Amazon co-purchasing metadataset, we build a model to evaluate the similarity between two items. We calculate three correlation factors to describe the similarity relationship and combine them with co-purchasing history record to generate the train and test data we used for naive Bayes and decision tree classification. Finally, the model we train can predict if two items will be purchased together in 87% accuracy. Here are our steps. Our dataset is Amazon Product Co-Purchasing Network metadata. This is a data format. Each item has the information of ID, titles, similar items, categories, and reviews. When we do the data processing, we obtain three factors to evaluate correlation between item A and item B. The first one is title similarity. It equals to the number of the same words divided by the number of the total words of title A and title B. The second one is the category similarity. It equals the number of the same categories divided by the number of the total categories of A and B. The third one is the rating similarity. We have two ways to evaluate it. The first one is the average rating of A and B. The second one is if rating A and rating B are both more than 2.5 or both less than 2.5, then the rating similarity is 1, else it is 0. After some coding, we transform the original dataset into the format of label point. The first column is the label of 1 or 0. If the two items are co-purchased, then the label is 1, else the label is 0. The next three columns are index 1, 2, 3, column title similarity, category similarity, and rating similarity.
The goal of our project is predicting if two items will be bought together by customers. In other words, we need to classify a bunch of pairs of items into two categories, co-purchasing group and non-co-purchasing group. Thus, we choose two classification algorithms, naive Bayes and the decision tree, to do this work. The input is the label point we generate. It consists of two parts, 25,000 pairs of items which were co-purchased in the past, and 25,000 of pairs of items were not co-purchased ever. Our application will randomly select 70% of input to be the training data and 30% to be the testing data. We also generate different size and different similarity combination input file. Try to figure out which similarity factor has the most great influence on accuracy and what is the relationship between accuracy and size of dataset. Here is a simple demo. In this demo, first we randomly select two pairs of items that are co-purchased and two pairs of items that are not co-purchased. Here are the information that we extract from raw dataset. Then we use our model to compute the correlation factors and parse the data file. This is the label point file we generate. Next, we input this file and use the model we train to predict if these pairs items will be co-purchased, and here are the results. As we can see, our model correctly predicts that First pair of items will be co-purchased, and third and fourth will not be co-purchased.
Here is what we found out. From the graph, we can tell that with the increasing data size, the accuracies for the two models increases as well. For the Bayes model, when the data size goes beyond 10,000, the accuracy pretty much remains the same here. Here are the particular accuracies of the two types of similarity measure of rating for the two models. The true accuracy means the ratio of the number of similar products which we successfully predict to be bought together to the total number of products actually bought together in the dataset. Similarly, the false accuracy means the ratio of number of non-similar products which we successfully predict to be not bought together to the total number of actually non-co-purchased products in the dataset. And the total accuracy is just the accuracy of our predict with the combination of the true and the false cases. Here we can see the numbers are pretty high to each other and pretty close to each other under the two types of rating similarity measure. So either type of rating similarity measure is acceptable in the analysis. Here we exclude factors of the categories, rating, and title similarity respectively. We see that when the category similarity is excluded from analysis, the accuracies drop down to 65% approximately. So it is easy to tell that category similarity is the most important factor in the co-purchasing relationship in our project.
This is our raw dataset. As we can see, each item has the information of ID, ASIN, title, group, sales rank, similar items, categories, and reviews. So now we will run the code to convert the original dataset into the format of the labeled point. Please wait a minute. We can generate different sizes of dataset by changing the number in the code. Okay. We can see that this is a label point format. Each line represents the information of an item, and if the first column is 1, then it represents the pair of items are co-purchased. If it is 0, then they are not co-purchased. And the next 3 columns are their title similarity, category similarity, and the rating similarity.
Once we extract enough information and generate the label point file, we can begin to train our model. To figure out which similarity factor has the most great influence on accuracy and what is the relationship between accuracy and size of dataset, we generate several different input files. For example, this is a file consists of all similarity factors and 50,000 pair of items. This is a file which consists of only title similarity and category similarity and 200 pair of items. Today, I will use the input file with 50,000 entries and all three similarity factors to show how our application works. The model I use today is naive Bayes. The application will first reading the file and randomly select 70% of them to train the model and 30% to test our model. Once generating the prediction result, it will compute the total accuracy, true accuracy, and false accuracy. True accuracy is the accuracy when the model classifies a co-purchased pile of items, and false accuracy is the accuracy when model classifies a non-co-purchased pile of items. Now let's run the code. As we can see, the accuracy of prediction is about 87%. It is pretty good. Further, we observe that the naive Bayes model had better performance when it predicts a non-co-purchased pair of items, in which the accuracy can reach 96%.
Here we define the functions of title similarity, category similarity, two different rating similarities, which is we're rating similarity 1 and rating similarity 2 using our predefined formula. Then we define the function called allPairs to extract similar and non-similar pairs from the dataset. So instead of generating the file of labeled data, here we just show a demo of 5 pairs each that will be written into the file. So for the similar pairs, we can see those values computed by the functions, which are title similarity, category similarity, rating similarity 1, and rating similarity 2. Here are the values of each pair. And similarly for the non-similar pairs, we can also see those values computed by the functions. Since those pairs are not co-purchased in the original dataset, so it is reasonable that the values for the title similarity, category similarities are 0.
After we finish the model training, we can use it to do some real prediction. Now, we randomly select 4 pairs of items to simulate the process of prediction. My teammate has generated the label point file for these 4 pairs of items. This is a file includes the similarity information about these items. Then we use the model we trained to try to predict if these items will be put together. Let's run the code. As we can see, the model predicts that the first and second pairs of items will be co-purchased. Third and fourth pairs will not be co-purchased.